Hello and welcome back to Switch and Lever. Today we're taking on a slightly bigger project, the creation of a Kant twist clamp. The plans this clamp was inspired by are linked in the description of this video. For good measure, the clamp was put through the usual CAD treatment to make sure all parts moved and reached as they should. Size was also adjusted and converted from imperial measurements to metric. We start with some hard 1.5mm thick steel, cut very roughly to size. Mill down one of the sides on each piece of steel so it's perfectly flat. Remember to deburr the edge once you take it out of the vise. Once we have both pieces milled, put them back together in the vise and mill down the opposite edge to make sure that the two pieces match exactly in width. Using the plans, map out where the holes need to go. Don't mind too much about the outline, other than to make sure that it's all inside of the sheet metal. Drill the holes in the appropriate places. Using a DRO helps greatly. Since both sheets are in the vise, we can be sure that the holes end up in the exact same places on both pieces. Deburr the edges of the holes and give them a small countersink. Once that's done, we can scribe the layout lines for the rest of the arm using the holes as guidance. You only need to scribe the layout line onto one piece of steel. The hole sizes were chosen according to the diameter of an M3 bolt, and as such they can be screwed together tightly and exactly. Roughly cut away more metal, leaving a little bit outside of the layout lines. When working this close to the bandsaw, remember to be very careful where you put your fingers. Grind down the rest of the metal on a belt sander almost all the way up to your layout lines. Since the screw heads protrude, a small piece of wood can be added under the piece for added balance. Remember not to let the metal get too hot, so cool it down often. Finish off the shape of the arm using files while still keeping them screwed together. Once done, remove the screws and finish up the surface as desired. The two smaller arms can also be done while using this exact method. Next, onto the pins. The pins were made from a rod of stainless steel, salvaged from one of the shafts inside of an inkjet printer. Start by turning them down to the required diameter and create a step down on the ends to fit the holes drilled in the sheet metal. Make light cuts as the diameter of the pins is quite small and will flex a little bit in the lathe. Use a cutoff tool to create the step downs. Since it's not a forming tool, it needs to be fed sideways to make sure that the surface has an even diameter. Repeat on both sides and cut off. Rinse and repeat for the rest of the pins. The shaft was also made from the same material, turned down to size to have threads cut on the outside. And right about here is where the camera battery died. Anyhow, once turned down to size, we need to drill a hole in the end and tap it to fit the screw which will hold the shaft in place. Be very careful when working with small taps in this hard material, as they tend to snap easily. It's also easier to leave the shaft on the lathe while tapping, as it will ensure that the threads are not cut crooked. Since we need to drill a hole for the handle through the head of the shaft, we might not want to cut the outside threads on the lathe, as they may get damaged while clamping down around them. The hole was started with a short ball-ended end mill, so the drill bit would have a good divot to bite into and not just deflect off the surface. Now, since we can't put it back into the lathe to cut the threads, we have to come up with another solution. By drilling a hole in a piece of scrap aluminum the same diameter as the shaft, we can make sure to feed it through perpendicularly to the surface being threaded. Take a pair of vice grips and clamp the threading die on the other side. Only a few good turns is required to get the thread started before backing out the shaft, put the die in the holder and continue threading. Remember to use cutting fluid, as manual threading requires quite a bit of elbow grease. The hinges which hold the shaft in place were made from the same stainless steel shaft material as before, and a very similar method as when making the pins was used to create the step-down ends of the hinges. Once out of the lathe, mill and drill where appropriate. One of the hinges need to be drilled to fit the thread on the shaft. Make sure everything fits together before moving on to the next step. Last items to be made are the gripping blocks. Square up a couple of pieces of brass and then mill them down to size. Once done, drill a hole to fit the pins we made in a previous step. The groove, which makes it easier to clamp around round objects, can be cut using a small engraving cutter. This tool is very simple to grind yourself if you have a piece of round tool steel. For instance, you can use the shaft from an old end mill and grind it down to a point, and then remove half of the thickness of the tool near the point. Time for some percussive assembly. Assemble all the pieces first to make sure everything fits properly. Once riveted together, it makes going back very hard. Peening rivets is not especially hard, but do take care when peening and rather use many light taps to get the rivets to fit perfectly than a couple of hard hits and find that the clamp seizes up because it compressed too much. Flatten the heads of the rivets and make sure that they mushroom out a little bit and sit snug in the hole. The handle was easily press-fitted into the shaft. For a more permanent solution, we could solder it in or use a bit of Loctite. You may also want to add Loctite to the small screw holding the shaft in place. And we're done! Be happy to have made such a nice and useful little tool. Thanks for watching! Be sure to subscribe for more videos from Switch and Lever.